Okay, so today we're going to be working on the tube hanger. This right here is the front view. This right here is the top view. And this right here would be the section view. Before we go into it, I want to clarify really quick that we do have this red square around our tube hanger. And that's just to indicate that the center right here is on the same level as the center right here. Now, typically in the normal drawing, the center right here would be on the same level as the top left corner right here. But in the drawing we're going to be working on today, these two centers are going to be leveled. I will say though that this is the front view for the original drawing, and this one is the front view for the drawing that we're going to be doing today. But the top view for the drawing that we're going to be doing today is, or would be, the same as the top view for this one. I can't say the same for the section view though. But if you need to do the section view for the original drawing, then this video will give you a pretty good understanding of how to do the section view anyways. Okay, so let's get started. Pick any point you want. We're going to start with the front view just because it's the easiest and it makes doing a top view 100 times easier. So I'm going to go ahead and start, or let's not do a line, let's do a circle at first. I'm going to pick 35, 15 because that's conveniently right over here next to our drawing. We can see that our first circle that we're going to draw, it would be the inner circle, or you could do outer, whatever you want, is going to have a diameter of 3. Then we're going to have another circle at the same point. It's going to have a diameter of 4. So now that we have these two circles, this is what I like to do. So I'm going to get a line, draw at the center of the circle, so 35, 15. And we can see that it goes over 5. So right here. But remember though that our red square tells us that these centers are on the same level, like the same x-axis. So instead of going to the top left of this corner over here, once we go left 5, that indicates that we're at the center of this circle now. So in order to draw what we would see if we were looking at it from the front, we would just need to go up by our largest circle right here is radius 1, so we need to go up by 1. And how wide is it? It says it's 1 wide. And then I would go 2 down, 1 across, and then back here. So now we have our little block right here, you see? If we were looking at this portion from the front, then it would just look flat, like a rectangle, like that. But we can go ahead and erase this line right here because we don't need it anymore. And we can do the rest of our drawing. So from here, if this portion, if these centers are on the same level, then we know that we're going to have 2 lines that are tangent to the circle, right? Because one line up here comes in contact with the circle at top, and then one line on the bottom comes in contact with the circle at the bottom. And these lines, we're just going to draw them tangent. So line, I'm going to do a snap override for tangent on a circle. As you can see, it snaps very nicely right there. Line, tangent, and bam, that's it. And if you want to find the area of it, an area of a certain cross section, let's say the area of this yellow section right here, then you can just go ahead and hatch. And you could do list or area, either works. So list, select object. It tells you all the stuff right here. So 6.920 would be right here. Or you could also do area, object, or you could just type O. O works too. And bam, area 6.92. So that's how you do the front view. Now let's start on our top view. So Let's draw a line and go up 7. It doesn't really matter how much you go up. You can go up by 8, 9, 10, whatever. So long as your end result doesn't collide with your front view drawing. I want you to imagine that this front view drawing rotates towards you 90 degrees, and so you would see the top of it and you would see how thick that circle is. The reason why we're drawing it, our top view, straight on top of our front view, is that it makes proportionality really easy. So what I just said, it rotating 90 degrees towards you, it applies here because your width of your circle is going to stay the same if you rotate it 90 degrees towards you, and you could use that to your advantage by seeing right here, your diameter in your front view of your outer circle is going to be 4, and whether you rotate it 90 degrees forward or back towards you or away from you, it's still going to be 4. So we could use that to our advantage right here by knowing that that's 4. Or you could look right here and see that the top is going to be a diameter of 4 no matter which side you come from. But in this case, our top view, we do need the thickness of the circle. So we see that right here, 1.5. And so let's connect that right here. There you go. So we'll go ahead and trim this piece right here. And using that knowledge that we just learned, we'll go ahead and do the same thing of proportionality with this line that's tangent to our outer circle. We see our intersection right here. So we'll go ahead and bring that up 90 degrees. Trim this piece. So now we need to figure out what this means. This line represents where our blue portion right here ends its intersection or its overlap with our circle. So we know that this big rectangle outside of here is our circle. It's the top of our circle. And this is the point where this blue portion stops its intersection over our circle. That's why we drew it straight up from this line tangent to our outer circle. We need to figure out its thickness though. Thankfully, it tells us right here, 0.75. So if its thickness is 0.75, then we need to find out how much space is on the outside of these to be able to put 0.75 inside. And for that, I'll use my quick calculator. So we're going to take the thickness of the circle, 1.5, minus the thickness of the blue tube, 0.75, which gives you 0.75. But that gives you the space on both sides, so divide it by 2 to find out the space on each side, which gives you 0.375. So I know that for this one, I'm going to need to go up 0.375, and then we'll just put the line right here for now. We'll fix it later, or we'll extend it, or whatever we need to do with it. 0.375, and then put that over here. Okay. So let's trim out our lines that overlap and then trim out anything unnecessary. So that'd be this part, this part, this part. Awesome. So now we found out the blue portion that overlaps with the circle. But now we need to find out the blue portion that is outside of the overlapping of the circle. And the way you do that is just by analyzing the photo. So we see that from the center of this circle to the center and edge of this drawing, it is the distance 5. So all we have to do is find the radius, which is the distance from your center to the outside of the circle, and then subtract it from this number, because this number brings us all the way to the edge. If we subtract it by the radius, then we're excluding the distance of the circle, which just gives us this portion, which is the blue portion, all the way to the edge of the drawing. And that's exactly what we're looking for. So the radius of our big circle is 2, because the diameter is 4. And so the distance would be 5 minus 2, which is 3. So we know that the rest of our blue portion is going to be 3 away from the beginning of its intersection with the circle. So let's do a line, put it by 3. Its thickness is 0.75. And then 3 again. You'll see it fits nicely right there. And boom. Now the last part would be this little portion right here. So we need to find out how long it is, and we need to take into account this 0.75 as well. So this 0.75 has already taken up a portion of this length right here in our top view. So we need to find the total length and subtract it by 0.75 to only find this portion. So the total, we could already see, we have 2 right here to the center of the circle. And as long as we find the center of this big circle, we can know the total length from the back of here to the front of here. So 2, and then the radius of the big circle is 1. So we have a total length from here to here of 3. And then let's go ahead and put it in the calculator. 3 minus 0.75, which is 2.25. So we know that outside of this blue rectangle, we're going to have 2.25 attached to it. So line 2.25. Do we know how thick it is? Yes, it gives us the thickness as 1. So 1 across. Oh, whoops, I did that right. Let's see. 1. There you go. All right. Then connect it. And there you go. That should give you your top portion. Your top view, you can shade it in with hatch or whatever you want to find the area. If you wanted to find the area of it, just do the same thing that we did last time. You can go in and put hatch, click it, area, object, bam, 3.444. And that's pretty much it for the top view. Finally, we have section view. So section view is a little more difficult. It's a little more complex, in which there's kind of more steps to it. You have to think it out a little more carefully. So I want you to imagine that we're looking at this drawing, and we have a cutting tool, let's say a knife, and we cut this drawing straight in half horizontally, like so, like in half. Well, you get the gist. Any side or any portion that touches my knife when I'm cutting this object horizontally is going to be drawn in our section view. So for example, we know that the distance from our first radius, which would be 1.5, our inner circle, to our second radius, which would be 2 for our outer circle, is 0.5. So when that's this length right here, our knife touches this area, so it's going to be drawn. And it's going to have a length of 0.5 because that's the differences of our radii. And that can be seen right here with our section view drawing. If we measure it, 1.5 by 0.5. The reason why it's 1.5 is because of the width of the circle, and then it's 0.5 because that's the difference of the radii. So the knife touches the outside part, so you have to draw that part. That's why this is shaded in with hatch. But the knife, when it goes through the circle, it's cutting it perfectly in half. It does not touch the inside of the circle though. That's why this part is not covered in hatch. Although when it reaches the other side of the circle, you do have to draw the same thing as you did on the right side. It has the same dimensions. And then the knife reaches the outside of the circle into this slanted area. But it doesn't matter if it's slanted because it's getting cut in half. And also this overlap right here doesn't matter because it only matters what the knife touches, and the knife is not touching the overlap, it is touching the middle of this. So we're only including the distance from the outside of our circle to our edge, which we already have from our top view. So if I remember correctly, that added up to 3, which makes sense because we have a length of 2 right here and then a length of 1 right here. And we include those, so we hatch those because the knife actually touches those portions. And then it moves on to the final piece to cut in half, which it touches all along right here, but it does not touch this inner circle, which is why there's no hatch right here. And then it comes out here, which is why there's a little hatch right here. So the dimensions would be like this, 0.75 thick, and then it would be 3 across because we have our 5 right here. Remember, our 5 from the center of this circle to the edge over here. We exclude that by subtracting it from the largest circle's radius, which is 2. So 5 minus 2 is 3. That brings us right here. So the distance from here to the edge would be 3. And that's exactly the path we cut along to, or we cut along. Then we just have this portion left over here. And we solve for that by having the total right here, kind of similar to our top view. We have 2, and then we have our radius of our largest circle would be 1, so 2 plus 1. The total would be 3 for this side right here. And then 3 minus 0.75, let's do it in the calculator, would be 2.25. So from here to the edge over here would be 2.25, which adds up. And then you want to exclude this portion, the circle, which is pretty easy. It makes it easy for us because it has a diameter of 1. And once you do that, you're able to solve for this part right here. We know it has a width of 1, and then we know it has a length of 0.75, because if you do 2 minus or 3 minus 0.75, that gives you the 2.25, which gives you this distance outside of the blue slant to the edge over here. And then you subtract that to get the distance in between them. And the radius of the small circle, as we said earlier, was 0.5 because the diameter is 1. And then that would give you 0.75. And then lastly, the outer portion right here, which we have 0.5 and 1, the thickness being 1 and 0.5 being the length. And we know that because, very simply because the difference of radii right here, the inner radius and the outer radius is going to be a difference of 0.5. So the outer radius is 1, inner radius is 0.5. 1 minus 0.5 gives us 0.5. And then we have the thickness is 1, so 0.5 and 1. And that's how you do the section view portion. If you have any comments or any questions, please make sure to leave them in the comments. I'll be sure to answer as timely as possible. Other than that, thank you.